Hello and welcome to Investigation 4.3, Generating Patterns. In this investigation, we are going to be looking at the properties of linear versus exponential versus quadratic relationships. And your job will be to analyze a table and figure out what would it look like if it was a linear pattern, what would it look like if it was a quadratic pattern, and what would it look like if it was an exponential pattern. So let's look at a few properties. Let's look at a few properties that define linear, exponential, and quadratic relationships. So, what does a linear equation look like? In a table, we have talked consistently about having a consistent change between the x-axis, seeing a plus 1, plus 1, plus 1, plus 1 change, and then that same consistent change or something similar in the y-axis. So, if we were to look at the equation that we have here, we have y is equal to 2x plus 3. If that was the case, we would be looking at if we had 2 times 0 plus 3, and we'd be able to write down a value. 2 times 0 is 0 plus 3 equals 3. Then we'd have 2 times 1 plus 3. 2 times 1 is 2 plus 3 equals 5. And we'd notice that we have a plus 2 change the entire way up this table. So if we were to actually graph this baby, we'd be able to say, all right, well, it's going to have a y-intercept of 3, and from there it's just going to be a straight line, a rise of 2 for every 1 over. So 1, 2, 1 over, 1, 2, 1 over, and blah, blah, blah. So we'd eventually be able to create a table and we'd be able to look at a graph. So our graph would be a straight line, but we would see this constant plus 2, plus 2, plus 2 relationship. Now, that plus 2 relationship, we can see also comes from our slope. So your job in this investigation will be to determine what is the true slope that is being created between one point and another point, and how would I maintain that slope to actually finish off a table that is a linear equation. And then from there you're supposed to write an equation, and you need to compare your work with the classmates' work, and it'll be fun. Very exciting. So let's look at the next one. What does an exponential equation look like? If I had those same values, 0, 1, 2, 3, 4 for x values, but we had this equation right here, y is equal to 3 times 2 raised to the x power, what would our graph look like? What would our table look like? So we have 3 times 2 raised to the 0 power. 2 raised to the 0 power is 1. 1 times 3 is 3. So we have the same y-intercept as the linear equation. If we had 3 times 2 to the first power, 2 to the first power is 2. 2 times 3 equals 6. So we're already slightly different in our equation. 3 times 2 to the second power, 2 to the second power, 4 times 3 equals 12. So what I'm seeing instead as we see this same change in our x values, we see that plus 1 difference, but our change in our y values is not an addition thing. It is, we see a plus 3 or a plus 6. That's not an addition thing. It's actually, if we looked at it, I'm multiplying this times 2. I'm multiplying this next one times 2. So if we were to follow that, we would say it's times 2 for our next one. So 3 times 2 to the third power. 2 to the third power is 8. 8 times 3 equals 24. So we should get 24 for our next one. So our final answer for 4 is 48. And our last little bit, if we were to graph this thing, we would have the same y-intercept, 1, 2, 3, but we would notice that it increases very quickly, and it ends up being a nice big curve off to the right. So it continually increases. Kind of interesting. Let's look at one last equation before you start in on the investigation. What does a quadratic equation look like? We've already talked about it. It looks like a big, huge arch. It'll have a maximum point. Or it'll look like a big, huge hole, and it'll have a bottom point. It'll look like a valley. So we have y is equal to x squared plus x plus 1. there's multiple x's in there. That means there's going to be two solutions for when the y-intercept hits. Let's do a little bit of math work so we can see how to make this table. We'd have 0 squared plus 0 plus 1 if we were going to have x equals 1, or x equals 0. 0 squared is 0 plus 0 is 0 plus 1 is 1. If we then had 1 squared plus 1 plus 1, 1 squared is 1 plus 1 plus 1, 3. Our next one for 2, if we had 2 squared plus 2 plus 1, 2 squared is 4 plus 2 equals 6 plus 1 equals 7. So as we know with quadratic relationships, we should start to see a second difference occur. So we won't see much with our first difference. We'll say this is plus 2. Our next one is plus 4. But we do notice after the next difference, 2 to 4, this should be constant. So we should see a constant plus 2. Let's check our next one. So we have 3 squared plus 3 plus 1. 3 squared is 9 plus 3 is 12 plus 1 is 13. So let's see if we have 7 plus 6 equals 13, and our next difference is a plus 2. So we can see that second difference develop. If that's the case, our next second difference, that's going to be a plus 2, so 2 plus 6 equals 8. We should see a plus 8 difference, 13 plus 8 equals 21. And that's our next number of this sequence. So if we were to graph this, we would have a y-intercept of 1, but it would continue up in one direction and continue up in the other. So our graph would look like a big valley, or a big, I don't know what else you would call that, just like a big parabola. That's really what it is. It's a big parabola. So we can see how our changes and our second differences can help us. For all of these equations, we can see how the first difference or the second difference helps us. Potentially it's a multiplier instead of an addition thing. We can see how these all change. Play around with this investigation. You're going to be looking at linear, exponential, and quadratic relationships, and you're going to be looking at very similar numbers, but they will behave differently with each pattern. So play around with those patterns. As always, if you have any questions, please ask, and yeah, I'll talk to you later. Bye.